the most flamboyant of flowers. South Africa's glory, burning to ashes. But, mysteriously, the fire brings new life, as it did to the phoenix, and soon the protea will bloom again. Within sight of Table Mountain, this group of flowers, the proteas, has evolved into a glorious array of colour, size and shape. The national flower, Protea cynaroides, is the largest, the size of a dinner plate. Others, the size of a tumbler. Such variety that, as early as 1735, the Swedish botanist Linnaeus named them after the Greek god Proteus, who could change himself into an infinite number of different shapes in order not to be identified. About 135 different protea have been named in Africa, and in just one flowerhead, over 1,000 small creatures have been counted, including spiders, beetles, bees and butterflies, and some which have still to be named. This insect life is inextricably bound up with these spectacular flowers. To these intricate arenas, they come to feed, to mate and lay their eggs, and even to prey on one another. Their comings and goings are of vital importance to the flowers. One can't exist without the other. The remarkable story of the proteas began many thousands of years ago in what is now tropical Africa. They spread south into the well-watered highlands of the Great Rift Valley. Eventually they reached the Cape, and here they flourished to an extraordinary degree. In this one small region, there are now 69 species that are found nowhere else. Amazingly, they flower in winter, between May and October, the season of heavy and persistent rains. To maintain themselves in this harsh environment of precipitous mountains and impoverished soils, the proteas have to make themselves conspicuous. Every flowerhead is a multitude of small, separate flowers, the florets. This species seems to be one of the closest to the ancestral form. Protea aurea is more specialised. Its candle-like bud opens to reveal a single spiral shuttlecock of florets. Here, not pink petals, but highly evolved leaves called bracts surround the mass of florets. Delicately bearded, the bracts now spread wide to reveal the 100 florets they once protected. The leaf-like bracts of Protea nerifolia completely shroud the inner florets, but they themselves make the flowerhead conspicuous, for they have luxuriant beards of black and white. Others display wide open. Protea magnifica blooms gloriously in the arid mountains. Each flowerhead has 1,000 plumed florets, surrounded by bracts that are sometimes red, sometimes paling white. Bushes, trees or shrubs, some hug the ground, and Protea amplexicalis unexpectedly opens at night. Each species has its own way of ensuring that its flowers are fertilized. The process begins as the flowerhead slowly opens. The bracts burst back, and the florets spring out one by one. Each floret consists of a tube of petals which surrounds the female part, called the style. As the style elongates, the petals spring back and lie shriveled in the depth of the flowerhead. When the petals curled back, they revealed a coating of pollen on the top of the style, which is called the pollen presenter. Only the very tip is left bare. Below, attached to the petals, you can see the black producers of the pollen, the anthers. They once surrounded the pollen presenter and covered it with pollen. The timing of this opening is crucial. It takes place before the tip of the style is ripe for fertilization, so the flower does not pollinate itself, but waits for pollen from another flower. The flower head opens, the florets spring out, and the bare tips are ready to be pollinated. For that, the flowers need assistance, and they advertise for it with their distinctive colours, shapes, and scents. Each species has evolved a way of luring deep into the centre of its flower head a creature that will carry pollen from one flower to another. The reward the messengers seek lies at the very heart of the flower: nectar, the food of the gods. Bees are especially attracted to this sugary solution. It's an essential part of their diet. A worker bee is a good potential pollinator. She may visit 500 flower heads in one day in order to collect for herself a pinhead of nectar. But Protea repens, aptly known as the sugar bush, gives a free handout. It's so rich in nectar that it oozes out before the flower even opens. A bee attracted to Protea lacticolor moves among the presenters and is dusted with pollen. Now she fulfills her task of cross-pollination. When she visits another flower of the same species, some of the transported pollen sticks to the bare tips and so fertilizes the flower. The bee is oblivious of the gift she carries. For her, the protein-rich pollen is another valuable source of food. She strips it from a presenter and deftly stores it in the pollen baskets on her back legs. A worker bee will even break into an unopened floret and steal the pollen. Not just a honeybee, but many other insects come to the proteas in search of food. The little solitary bee, already heavy with pollen, works hard with its mandibles to break open the floret, to reach the pollen beneath. The praying mantis, sometimes called the Hottentot god, is no pollinator. For it, the protea is a predator's paradise, a gladiatorial arena where the victim is unsuspecting. It eyes its prey, taking time to strike. There's no escape, and the delicate jaws nibble the prize. But the protea provides a stage for more drama than just thieving bees and their attackers. Protea aurea. Even before its flowers open, the tufted bracts surrounding them are shaking with insect activity. The destroyers, 1 1/4 inch scarabs, called green Protea beetles. The mature beetles seem to appear from nowhere. In fact, they've spent the 2 previous years as larvae in black termite mounds, emerging in the autumn when the proteas begin to bloom. Found only on proteas, they carry pollen on both their mouthparts and special yellow tufts. But their value to the proteas as pollinators is insignificant. They plunder greedily, but give little in return. By August, they fill the airspace above the protea with a buzz of colour. They land and take off in hundreds. They visit the flowers to fuel with nectar, the energy source for their thieving life. Being so large, they need a lot of energy to fly, and their body temperature is critical. Before it leaves, a beetle sits on a flower head and pumps, flexing its muscles as it takes in oxygen. It's been discovered that this may raise its temperature by 12 degrees centigrade. Only then does it have the available energy to take off and find a new flower to feed upon. They swarm around the base of the flower, seeking not just nectar, but also the hidden pollen. And, like the bees, they break into the unopened florets. Many florets are destroyed, but not all. Look closer at this flower head. It's seething with life. The most common inhabitant, tiny flightless mites. But if they can't fly, how did they get here? Can they be pollinators? And what are they eating? It seems that some species of mite attack visiting insects, while others scavenge dead organic matter or pollen. But when a beetle clambers up and prepares for takeoff by pumping, the mite's behavior changes dramatically. Something in the beetle's movement or scent must attract the mites. They rush up its legs and swarm all over it. Perhaps they're after fragments of the floret stuck to the beetle's carapace and benefit the beetle by cleaning it. But this beetle doesn't appreciate them. They assemble under its chin where there's an accumulation of food fragments and where they can't be reached by the flailing legs. But whatever the mites feed on, the green Protea beetle is their carrier. Transported to a new flower, the mites slip off and found a new colony, and perhaps help pollinate another Protea. Protea nitida is quite dazzling, so it's not surprising that there are uninvited guests. The little white eye is not a regular pollinator, it's just come to find insects. This double-collared sunbird is of little value to the Protea either. It may never come into contact with the pollen presenters. Nor does the orange-breasted sunbird. They both use their long beak and tongue to probe the bracts and suck up the nectar. Sometimes they move over the pollen-covered florets in search of insects as well. But there's one animal whose life is more closely bound up with the Protea than any other bird or insect. It's the Cape sugarbird, found only where the Proteas bloom. The male, easily recognized by its long tail, sits proudly on top of a Protea bush. The shorter-tailed female feeds on Protea nerifolia. Unlike the wide-open Protea, commonly pollinated by insects, this one is adapted to attract birds, and it does so not with a scent, but by being tall and reddish in colour and offering a great abundance of nectar. Since few other flowers blossom in winter, the sugarbirds feed almost exclusively on Protea, taking both nectar and nectar-feeding insects. A sugarbird may visit 250 blooms in a day to get all the food it needs. As the female's beak goes deep among the pollen presenters, her feet spring open new ones, and her head gets covered in pollen, the reddish-yellow dust on her forehead. She'll carry this to pollinate the next flower she visits. Competition among Cape sugarbirds isn't just for flowerheads to feed on. They breed here and rear their young during the winter flowering of the Protea. The male selects a territory, a clump of Protea bushes with a few advertising posts and a suitable nesting site for his single female. He defends it against other males by singing and flaunting his feathers. Master of all he surveys, he proclaims his courtship song. And in an aerial display, he dances to his female. In quick flutters, he rises and falls among the bushes, where the female is plucking Protea seeds to line her nest. Her nest lies hidden in the centre of a big-leaved Protea bush, protected from cold winds and predators. She alone makes the cup-shaped nest, with Protea leaves lined with fluffy seeds and tufted bracts. Now the nest is finished, and she feeds mainly on insects, high in protein for egg production. She plucks them from the air. Meanwhile, the male drinks the sugar-rich nectar. He needs the energy to defend their territory. The female lays 2 eggs and sits incubating them for 17 days. She leaves for short feeding sorties about every 2 hours. She sits, calling gently to the male nearby. He neither incubates nor visits the female, but keeps a watchful eye within their territory, preening his plumage for future displays. Once the eggs have hatched, the female begins collecting food, nectar, small insects and spiders. Only one chick in this nest, 5 days old. It's fed 20 to 30 times a day. Occasionally the male brings food as well. Having fed, the young ejects its fecal sac, which the female takes and drops discreetly at the edge of her territory. When the northwest wind blows during the breeding season, there are more rainy days than sunny ones, so the chick's development may be held back. But the flowers flourish in the rain, and the Cape sugarbird continues to visit and pollinate them. The female may spend all the hours of daylight collecting food for her nestling, now 12 days old. Cockroaches, flies, bees and ants all find their way back to the chick, and on the female's forehead, telltale yellow pollen. The chick quickly gains weight and after 18 or 19 days flies from the nest. The parents continue to feed the fledgling for another 21 days, but then chase it from their territory. This interrelationship between the birds, flowers and insects is so remarkable that it's difficult to imagine how it evolved. But there's an even more unexpected story up in the highlands of the southwestern Cape. Here, dense Protea bushes have flowers so hidden that it's unlikely they'd attract any insect or bird. And Protea humiflora, which flowers near the ground, opens at night. So how is this flower pollinated? The answer began to emerge a few years ago when 2 scientists decided to look beyond the flower itself. Occasionally they found a seed head or pile of seeds a little way from a Protea bush. Some had been chewed. Elsewhere, one flowering plant was linked to another by barely recognizable runs. Sometimes they were dotted with tiny droppings. Added to this, the pendulous flowers had a yeasty smell, and the bracts were fleshy and tasty. Only after dark did they discover the identity of the mysterious visitors. Small rodents, and most commonly the nocturnal Namakwa rock mouse. In the still of the South African night, guided by the yeasty scent, the rock mouse clambers up the bush. Firmly attached, the flower oozes nectar at night, and each night another spiral of pollen presenters spring open, offering a new abundance of pollen, which gets dusted onto the visitor's nose and whiskers. Food is short in winter, so the secret flowering Protea is of great value to the mouse. Even the bracts are edible. And during the flower's 2 months of blossoming, the mouse is an essential visitor. As with all the proteas, Protea humiflora has evolved its own way of attracting a specific pollinator. And for all the proteas, fertilization of the bare tips leads to the production of seeds. Though the mouse eats the seeds it pollinates, and the Cape sugarbird lines her nest with them, many lie hidden and are overlooked to germinate later. But there are other proteas which have evolved an even more precarious way of ensuring their future survival. When the florets of Protea repens have been pollinated, the bracts close so tight that the seed cases may survive on the flowering shrub for 10 or 20 years without releasing their seeds. Several species do this. It appears totally non-productive, but they're waiting for a most dramatic life-giver, once thought to be deadly. The life-giver, fire. It may destroy acres of proteas, leaving no sign of life, but it clears the old and makes way for the new. The tightly closed seed case begins to open and curl back at the tip, turning to ash. The fire passes quickly, and the lower bracts still protect the seeds within. 5 days later, the land is black and dead, but there's one change. The seed cases, deprived of sap, have fallen and opened to expose the new seeds. As the wind blows, it catches the feathered parachutes and carries them away to germinate in the autumn rains. So, from ashes, new life blossoms. From seeds and hidden roots, the glorious proteas return. Within a few years, the countryside is ablaze with colour, luring once again their life-giving pollinators.